Okay, so we go on with chapter number 3 about understanding structure. Okay, so basically, it should be even that you have the very basic programming. You should follow some very basic rule to have structure program, right? So in the case of the unstructured program, sometimes they call it spaghetti code here. Spaghetti code, that means it's not really normally you have very confusing code. You often have the complicated math and program work, but very difficult to understand or read and maintain program, and also we have the confusing and prone the error here. And that's why even with a very basic program, you should follow some very basic rule to have the structure here. That is examples of the program is code everything overlap together, and you can see it not even that it works, but it not efficient to your program. Now you should understand the 3 basic structure of the program. So basically, for every program from now on, you can see that for every program, it is a combination of the 3 structure here. The first one is the sequence structure, the second one is the selection structure, and the third one is the loop structure. Whatever it is, even the complicated program, it is always a combination of 3 structure here: sequence number, selection structure, and loop structure. What is sequence number? Sequence number, it is perform action or task in the order. I think about you have the many line of code. It works from the last statement to the last. From the first statement to the last statement. Everything in the order. That structure. That is sequence structure here. The second one is a selection. The second one is selection structure, or sometimes they call it the decision structure. That means you have the condition to check. You have the condition to check. If it's true, you go to the sum. You can do something. If not, you can go to the other thing. Right? And you have the 2 selection structures. The first one it's a single decision structure. The second one is a dual alternative. And later on, I will explain what is a single alternative and what is a dual alternative. And the third one, the loop structure. Again, loop, you have the condition to check. But if the condition true, you keep go back and doing it until the condition not correct here. Right? So that is the sequence structure here. Everything works in the order. Everything works in the order from the first statement to the last statement here. Now it's a selection structure. You have the condition to check. Right? If yes, you do something. If not, you go to the another branch and do other thing here. Right? That is the dual alternative here. And the third one, now about the selection structure, you can have the dual alternative or single alternative here. Now think about this one here. This is example of dual alternative. You have the condition to check here. So this program is very simple, right? It asks you what is your, asking you to input your age, right? And check the condition. If your age is greater than 18 or equal 18, you are eligible to vote, but you are not eligible to vote. So the code it is a dual alternative because you have the two alternatives here, right? Because you have the 2 alternatives here. If it's correct, you are eligible to vote. If not correct, less than 18, you are not eligible to vote. So you have in the case of dual alternative, it contains 2 alternatives, and sometimes they call it the if then else structure here. So see, you check if that's why you see in the case you work with the Python, you have the condition here to check here. If here age greater than or equal 18, you are eligible to vote. Else, that means you are not greater than or equal 18. You are not eligible to vote here. So you can see it in the pseudocode here. In the case of pseudocode for this program, it's very simple. You see, you got inputted from user, and you check the condition here. If age greater than, you print it out. Else, that means not here, right? You print it out. So in the case when you work with the raptor also, when the case we work with the raptor, it's very simple. When you work with the raptor for this one, now in the case the raptor, you have option when you work with sorry. So in the case raptor, you see you have option for selection here. That is the case you work with the selection, right? So think about this one. This program, I go back to my slide here and I open it here. You can see my program here. So I got input from user. I store it in the variable name h here, right? And now I check the condition. If h greater than or equal 18, you are eligible. Not yet. So I can run. If I enter the 25 here, you see it's a 25. The condition here, the correct true. It goes to the yes, and you are eligible to vote here. Right? That's why you see it's output here. But if you enter 16 here, see the condition here is no, right? Not correct. Right? You are not eligible to vote. Right? That's all. It's very simple. In the Raptor, in the Python also. Very simple. The Python here. You got h. I'll go in the h here. Must be integer format, right? You cannot 16.2 or 0.5 here. That's why I convert it into the integer format here. And I check the condition. That's all. That for the Python. If I enter the number here, and if I enter the number 16 here, now that is your alternative. That is your alternative. But sometimes you have the single alternative. Single alternative here. I think about you only have one alternative. If the condition true, you do something. If not, don't do anything. It doesn't do anything here, right? So think about that. If employee belong to the dental plan, then deduct 50 here. That means if he don't belong, don't do anything. Okay. So the else is not required. So that is the case. That is the case here, right? You only have one dual or one single alternative. You check the h here. If h greater than 18, you are eligible. But this one, don't do anything, right? Okay. So in the case of the Python also, you just do the single alternative here. Now you have the three basic structures. The first one is a sequence. You do with everything in line, right? Everything in the order. The second one is a selection or what's the name? Decision structure, right? You have the condition to check. Yes, do something. No, do other thing or don't do anything here. Now the third one's a loop, right? The third one's a loop again. When you work the loop, it is an option. Sorry, it's an action. You repeat a set of action while condition remain true. So if the condition remain true, keep doing it until the condition not true here, right? And for you have the loop body, and also in the loop body, for each time the loop execute, they call it the iteration. Iteration, that means it will execute the whole body of the loop one time. I think about when you processing for a student here, each student they execute one time, that one iteration, right? And the correction is that first is the most common loop. That's why you have the pre check loop here, and you can have the while do or while loop here. Now this one in this one I work with the loop in the Raptor and in the Python here, right? So you see this program here. The purpose of this program is to get a number and I double it. I print it out. What is double here? But I want to do it for multiple times. I want to do it for multiple times, right? Multiple times until I enter the number 0 to exit. Right? So you see, you follow exactly the same with the mainline logic. You can think about this one. You can think about this one. It's the housekeeping here, right? Because see, when I go to the loop, I have action here to check if number equal to 0 or not. If number equals 0 or not. But one thing is very important. You have to pay attention here. I mentioned it once, but now I want to repeat it again. There's something very well in the Raptor here. So basically, in any other programming language, in any real programming language, if the condition true, you keep doing it. You keep doing the body of the loop. But in the Raptor, you see, if the condition true, you execute it. That's why when you convert something interrupter, you have to pay that attention here. Right? So actually, the condition 2 interrupter, you exit the loop, not execute the body of the loop. Right? So see, that's the difference here. In the case of the Python, if the number is not 0, keep doing it. Right? That's why I put 0 equal here. That means not 0, not equal to 0. But on this Python here, I have to check if number equal to 0. Right? Okay? It's very important when you convert interrupter. I don't know why it makes so confusing interrupter. So you can think about this one. That is housekeeping because my number here, you have the condition to check in the loop. It's a body in the loop. That's why you have to initiate it before and outside the loop. And I said, if my number not equal to 0, you say double it, print it out. You see, at the end of body of the loop, I need action to get the new number in order to come back to check the loop here. If not, I have and this loop. Okay. So for this one, you can see you can do the same with the Python here. You can see you do same with the Python. You see that is the keyword y. That is a loop, and you know this is a value. Sorry, this is variable who controls the loop here. That's why I need to initiate it before and outside the loop. Before and outside the loop here. So see, every time I double it, I print it out at the end of the loop. I need action to get the new value of the variable who controls the loop. Make sense? Okay. So basically, from now on, you can see any program is a combination of 3 basic structure here. You have the sequence, you have the selection, and you have the loop here. So for the loop structure, you have the while, and that condition continue to be true. And if continue to be true, you do something. You do something here. And of course, in the Python, in the pseudocode later on, you see you have the keyword here, y and ny. That means what? And the loop here, right? And also see why you continue to be hungry, take another bite of food, determine if you still hungry or not. If you're hungry, keep eating, right? And you have ny. Okay, now the combining structure. Again, I mentioned that every program it is combination of the 3 structure here, right? On logic pro can be solved using only sequence, selection, and loop. And structure can be combined in infinite number of ways. And you have the stacking structure, and you have and structure statement also. Now think about this one is a combination here. That is combination structure here, right? So you see you have everything about this one here, doing this sequence here. This one here, selection here, because to break it down. And this one here, loop here. And from now on, you can use the combination of the 3 structure here. You can net them in together, or you can stack them on top of each other. It's totally up to you, and you are flexible with that one. Okay, any unusual task or step structure can be replaced by structure. You have the netting structure, right? You can net them together, or you can block. Block is a group of statements that execute a single unity. Now think about this one. What do you think? What is the combination of this one? If you look on this coding, what is the combination here? You have you can see here is the sequence here, right? And you put the sequence inside the selection. That's all. You see, you can use the selection. Think about this one. If you are greater than 18, you are eligible to vote, right? Vote for Biden, vote for Harris, and so on. That's all. Okay. Now, how about this one? I say this one is a net structure, right? Is sequence netted within the selection. How about this one? What do you think about this one? What is a combination for this one here? What is combination here?
That 2 selections in sequence, or selection, sequence, and
what is it?
Structure.
So basically, this one here, when you want to when you want to understand about the structure of this one, you have to look from inside out. Right? So basically for this one here, that is inside here. That is a loop because you see, if condition true, you go back here, you go back here. That is a loop, right? So we have a loop netted in what? Sequence here, right? Netted in sequence. And again, sequence here, you netted in the selection. Okay, you have when if you want to understand the structure of this one, you have to look from inside out. This one you have to look, you put it inside the sequence, and again for this sequence, you put it inside the selection here. Right? Okay, so we see netted here. Look, netted within the sequence and netted within the selection. And again, how about this one? Again, you see for this one here. Right? Everything here. Now you have to look from inside out. This one first, right? This one selection, right? Inside the body of the loop, right? And the loop inside the sequence, and again sequence inside the selection. Right? That's all. So we see you can look at it everything on the pseudocode here. See, look everything in the pseudocode here. You can see, right? You put everything here, sequence inside the selection. Because whenever you see if and else, it is a selection, right? This one is single alternative. And again, for the second one, you can see the second one here. You can see you have to look from this one. The Y here inside the sequence, and again the sequence here inside the selection. Okay. In the third one here, you can see also what happened here. You have to look from inside out, right? This one selection here. Inside the body of the loop, again the loop inside the sequence here, and again the sequence inside the selection here. Okay. Okay, now structure program has the following characteristic here. What is it? Include only combination of three basic structure. Every program, remember that, includes the only combination of the three basic structure here. Each structure has a single entry point and the single exit point only, right? And structure can be stacked or connected to another only by the entry or exit point only. Any structure can be netted within another structure. It can be netted anytime you want. Right? Now, I mentioned about using your programming input to structure program. What is the programming input? Programming input, it's the first input data record. Right? It's must be outside of the loop. You can think of programming input is in the body of the housekeeping. So programming input is the one you need to initialize the value before and outside the loop. Right? You can come back to my example here. You can come back to my example here, and you can think about this one. You can think about this one. What? Go back to my slide here. This one, right? You can think of this one. So this one here. Again, for this one, you can think about this one here. Now, think about this one. My number here is the primary. Why it needs to be very important here? Because see, you have the condition here to check in the body of the loop. That's why you have to initialize value of the variable who controls the loop before and outside the loop, and they call it a primary input here. This primary input here. Prime input, normally, if you work with modularization, they put it inside the body of the housekeeping. If you work with modularization, you put it inside the body of the housekeeping model. So the prime input is very important because you need to initialize it before and outside the loop in order to go to the loop, because the loop you have the condition here. Okay, that's the thing you have to pay attention when you work with the prime input here. Again, the same when you work with the Python also. When you work with the Python here also. You need the action to get the value of variable who control the loop before and outside the loop. That's the first thing. That's the first thing about structure program. It's very important. Okay, so we see about the primary input. You have to read the input. Read the first input data record. It's outside the loop, and that reads the rest of record and have the keep program structure. And also, what is it? Now, think about this one here, right? Think about this program here. You want to keep doing it for many number, right? Every number you just double it and print it out here. Right? So what's wrong with this program? What do you think? If you look on the flow chart here, what's wrong? What's wrong with this program? What's wrong with this program? What do you think? If you look on this program, what's wrong?
There's nothing to
One
declare
is
the end
quite-
file.
Yeah, actually this one, it should be original number. Think about keep doing it until it is not equal to 0. Not equal to 0. So basically, you see, you need to get the input. You need to get the input here, right? Of the from before and outside the loop. But at the end, you need the action to get a new number. Right? Otherwise, it is the end result. If you look into the program here, right? If you look in the program here, you can see what happens in the program here. If you delete this one here, you can see what happens. It is endless loop. It's running forever, right? Because you see, if I enter the number 10 here, if I enter number 10, check. No, right? Double 20, print out 20. Come back again. Number here stays the same 10. Do it again and again and again and again forever. Right? That's why, see, when you work with a structure program, you have to initialize the prime input before and outside the loop. Also, at the end of the body of the loop, you only have action to change the value of variable who control the loop. This one, okay, because see, the keep the same if you need the end loop. Okay, I know so this one also don't do it because they recommend that for the structure program you should get the input, get the prime input before and outside the loop. Of course, when you work with Raptor, this one works, but it's not structure they recommend it. You have to put it outside. Okay, that is structure. That is structure here, right? You see, you got the prime input before and outside the loop. At the end here, you have the action to change the value of variable who controls the loop. Right? That's a very simple rule here. You should follow when you use a prime input to the structure program. So this one, don't do this. This come back. Okay, now understanding the reason for structure, use structure program for clarity. Of course, everyone follows the same standard. Right? You see, it's very easy for you to follow up what's going on with your program here. Professionalism as a programmer. Also, if you say this bucket, right? Think about you have the program and you want to hand over to someone. If you guys follow the same standard, very easy for you to see your program here. Efficiency, mode language supported. Maintenance as a programmer, quite easier to read, and modularity easily broken into the module here. Okay, so some very recognized structure, very simple with this one. You can see what this one, right? I don't want to explain about this one again. It's very simple. Oh, that's all. That's all for the module number 3. It's one. Okay, so we still have time. I want to do something with some of the function in the raptor here. The first one, the random function here. Random function is random to generate random number in the range from 0 to 1, but not includes number 1. So basically, when you work with random number here, generate everything in the range from 0 to 1, but not include 1, right? So basically, you can see it can generate here. It can generate a 0 or 0 0.123 or 0 0.89 or 0 0.9999, but never ever go to 1. That's the first thing you have to remember. And you can check. You can check with your random here. You can open your raptor. You open the raptor and you can do something. So when you work with the raptor, you can open the raptor here. You see positive program. You can see positive program here. If I want to do it for 10 times, I want to do the left for the 10 times. That's why you can see and think about this one. If you look on the raptor program here, if you look on the raptor program here, I want to print it out random number for 10 times. And this one, again, when you learn about loop, you see you have a 2 type loop. The first one is a definite number of loop, right? Number of iteration, and the second one is indefinite number of iteration. So this one is a definite number of iteration. You know for sure you want to do it 10 times. Right? So normally in that case you maintain the counter. Right? And you can think about that. The prime input here, I need a counter. The first one, number 1, I check the condition here. If greater than number 10, I exit it as a y. I just print it as a number here. And you see, at the end of the loop here, you have the action. You have to change the value of variable who goes to loop. If you do not have this one, it always stay at 1, and it ends this loop forever here. Now for this one here, you can see I run it for 10 times. Right? Sorry, I run it here. It print it out for 10 random number. I run it. First one, second one, the third one, the fourth one, 5, 6, 7, 8, 9, 10. Right? That's all. It prints out the 10 random number. You see, everything here is range from 0 to 1, but never ever includes number 1. And if you want to verify, you can do it for 1,000 times. You can see, or more than that. It never ever goes to number 1. And to use a random function in the raptor here, use random. Random here is a function. It will generate the number in the range from 0 to 1, but never ever includes number 1. Make sense? Okay. And you can observe my program here. You can see in the program here. The number 1 here, the counter here is the prime input. You need it in order to go to the loop. Anytime if you delete this one, you got the syntax error. Also, if you delete this one, you have endless looping. Right? Now, my question here. That one only generates the random number from 0 to 1. What happens if I want to generate random number from 0 to 10? How can I do it? Think about that. How can I do it? Or 0 to 100, because I think that is my grade here, right? Everything from 0 to 100. This only one from 0 to 1. How can I do it? What do you think? How can I do it? If I want to generate random number from 0 to 100. How can I do it? Yes.
We multiply the value by 100.
Yes, that's all, right? The thing is it here, see, this one here. This one here only generates from 0 to 1. And of course, if I want to 100, I still time it to 100 here. Let's see, 0 to 100, you have 0. 1 to 100, you have 100 here. And that's all. Let's see, I can modify my program here. And you can see what happened with my program. So I time it to 100. So you can see, now I run it. So see, 65, now and so on. Right? And so on. Right? Okay. Make sense? Okay, now what happened? That is about the random function. You see, you have everything here. I explained it already to you. Now, what happened if you want to generate random integer number? You see, everything here is a floating point number. It's a floating point. So, yeah. Again, and you have everything here, right? Okay, now, so you see, when you run with this program, when you run with this program here, run it again, one time, you can see here, the counter keep changing here, right? Because every time you increase by one here, and you see, whenever you go to the 11, it stops. Right? See? And of course, if you do not have this one, it always stay at one and it do it forever. Do it forever here. Right? And it's look here, one of the very common mistake here. Because you see, the counter here always stay at one. You check the condition, never ever true, right? Keep doing it, keep doing it, keep doing it, keep doing it forever. Now you have action to bring it back. Okay. Now, if you look on this program here, everyone in the range from 0 to 100 here. But what happens if I want to get the integer part of it? So in the case of the router, you have the two options. You can use a function. You can use a floor function or ceiling function. So the floor function, it will round every floating point number into the integer, round it down, right? So we think about if I have the number here, if I have the number 78.34 here, so when I use the floor function, it will round it down to integer number 78 here. And in the case of the ceiling, it gives the case of ceiling here. And you have the 78 for 4 here, you round it up to the next one, you have the 79. Now, what happens if I have the floor function and I put is negative 15.3 here? What do you think? What number I have?
14.
What is it? Down.
No.
Down. Floor down.
Negative 16.
Yeah, 16. Negative 16. Yeah. So you have negative 16, and if you use the ceiling, you have 15 here. Negative. Okay. Now you see, when I can modify my program here. I can modify my program here, right? So I have it to the 100 here. Now I use the floor function. Everything inside. So you can see what happened here when I run it. Where am I? Yeah, see, everything here is a whole integer number. Whole integer number. Make sense? Now, my question here. What happened if I want to generate random number in the range from the 5 to 15, random integer number from 5 to 15? How can I do it? How can you do it? Give me the answer. How can you do it?
But then you do somewhat sort of the same answer. Oh wait, no, you could do a like a times 5 and a times 15, but do a
Yes.
greater than 5 and less than 15, or greater than equal to. Yeah. I don't know. I'm bad at explaining things, so.
Yeah. Okay. The thing is, you are so close about that one. The thing about this one, when you range about the 5 to 15, the first thing you have to identify how many numbers. How many numbers?
2.
5 to 15. How many numbers?
Like between them, 10.
Actually, you have 11.
Oh,
Right? From 5 to 15, you have the 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. You have 11. Right? So the first thing is that you know that you need to generate 11 number, right? So basically you have to use a random here. Times 11. Right? Because random only from 0 to 1, but now we want to generate 11 number. Right? Now, you see, when you work with the random from 0 from time 11 here, actually you generate every number in the range from 0 to 11, but not include the 11. It's not included 11 here. Now, here's the range from 0 to 10 here. You can have the 10 here. You see, from 0 to 15 here, you see, the gap here is number 5. So basically, user add 5 to this one. It will generate every, yes.
so if you did 11, then you could get like 10.5 or something.
Sorry?
You could get like 10.5, right?
10.5?
Yeah.
Yes,
10.5.
for this one.
Yeah.
No,
10.5 plus 5.
No, sorry. From no, for this one only 0 to 10 only, not include. From because here I go to the 11, 0 to 10, 0. No, from 0 to 10 only, because you see from 0 to 10 you have the 11 number.
So it wouldn't be random times 11 plus 5, it would be random times 10 plus 5.
So say again.
It'd be random plus 10. Sorry, random times 10 plus 5.
No, not random time 10.
Random times 11.
No, see, random time 10 it only generate 10 number only. Everything you see, I can show it here. If you have random time 10, you can see. Time 10 here, right? You can see here. Let's do it for 100 times. So you can see what happened. It never, it never ever.
Because you're using floor.
Yeah. Yes. That's why I'm using floor. Right. That's floor. Yes. Right. You're right. That's fine. Never ever include. So basically, in order to generate random number, integer number from 5 to 15, you know that you have 11 number, right? So the first thing you have to use a floor function. You use a floor. You have the random function. You time it to 11 because you want to generate for 11 number, right? Okay. If you use your floor, it is a floor here. It generates every number in the range from 0 to 10. Right? And of course, after that, if you want to generate from 5 to 15, you just add 5 to this one. That's all. Right? Okay, makes sense? Okay, so that follows the same. The first thing, you have to identify how many number you want to generate. And the second one, what is the start number? That's all. I think about this one. If I want to generate a random number from -5 to 5 here, I have to follow the same. Actually, from -5 to 5, you have 11 number. And this one starting number, so I have to minus 5 here. Make sense? That's all. That's the case you want to do in the interactive. And of course, you sometimes you can use a ceiling function. It's up to you. It's up to you. But you have to understand that the floor function always round it down, and ceiling function is round it up. Make sense? Any question? Okay, so we can use a floor function or ceiling function. Not equal to 10, you times to 10, and it's a range from 10 to 20. You have the 11 number, you have to time it 11, and you plug in 10. Okay, I think that's all for today. That's all for today. You have a lot of work with today. But again, I just want to remind you again for the module number 2. Some very important thing you have to grasp the concept of very basic concept. The first one, modularization. Right? You know that when you break it down, modularization, you a lot of benefit. And when you work the module, actually you call the module. When you call the module, it's jump into the module. It secure everything from the first statement to the last statement. And you go back to the main to the module who call you, and you go to the next statement. That is a very basic concept when you understand about the modulation. The second thing about the mainline logic, also we have to understand it, right? Mainline logic, they have the 4 components. The first one is declaration. The second one is housekeeping. It's very important. It's housekeeping. You have to initialize the value of the variable who controls the loop, right? Before and outside the loop, right? And in the main body of the loop, you have the action to change the value of variable who controls the loop. Okay, that is something very basic thing, but it's very important when you understand the basic coding and mainline logic here. So come back and do the homework and assignment, and anytime I said that anytime, if you have any challenge, just send me email or inbox me, or you can join my office. I'm here to help you. Okay? And again, at normal, I will upload the recording into the announcement, that in case you want to look it back or watch it again. Okay? Any question from you?
Did you already take attendance?
Yes, I will.
Okay.
John, are you here? John, are you here?
Yes.
Gabrielle, are you here? Matt, are you here?
Yep.
Jeremy, are you here? Jeremy, are you here?
Yes.
Luke, are you here? Grant here. Sawyer, are you here?
I am.
And G, are you here?
Yes,
How to pronounce the name? You want?
you was right, Unji.
Okay. So I see you guys on next Wednesday, because we do not have class on Monday. It's like that. Okay. See you guys. Bye bye.
Yeah.